Welcome to 1.6 notes. We're talking about function operations. And when we have operations, any sort of adding, subtracting, multiplying, we can do those with functions as well. So as a reminder, you can add, subtract, multiply, and divide functions. And this would come in handy so many times. We could talk about your gross profit minus your expenses. We can talk about a washer, things like that. They all come in handy. But as a reminder, when we're talking about our domains, so your combined domain is now your common domain. Basically saying if you have a domain restriction on a function and you're going to combine that with another function, you now need to use that domain restriction. So when we're looking here at f of x, g of x, and h of x, we can take just a little bit of a side note here that we have a domain restriction of g of x where x has to be greater than or equal to -2. So we're going to keep that in mind when we're combining g of x, because we're actually going to go ahead and we're going to start with f times g of x. In this little notation, you can see it in a few different ways. Simply just taking your two functions and multiplying them together. So we're going to take x squared plus 4x times the square root of x plus 2. Now, this one's not that fancy. We can't really do anything with it, so we're going to leave it there. But we are going to go ahead and also just state our domain is going to be from -2 to infinity. So as a reminder on that, you do have a domain restriction because g of x is part of that now. And you can also you can find some inputs. For example, here we're going to take f times g of 3. And option 1 is that you just go ahead and we're going to find, my page is moving here. We're going to find f of 3 first. So we're going to plug in 3 squared plus 4 times 3. 9 plus 12 is 21. And then I'm also going to find g of 3, which is the square root of 3 plus 2, which is the square root of 5. Meaning that f times g of 3 is equal to 21 square root 5, because we just go ahead and we take these two outputs that we found and multiply them together. You, of course, could also just plug it into this function that you found before, but sometimes we don't find that first, and we can go ahead and we can jump right to this step. So now that we've done that, let's go ahead and look at dividing some functions here. So let's do h over f of x. Well, that's going to be 3x plus 5 all over x squared plus 4x. And because we're dividing functions, we introduced a domain, right? We have now a denominator, and we just want to double check that. So we're going to go ahead and solve for what x cannot be, which would be x squared plus 4x cannot be 0. I'm going to solve that by factoring, meaning x cannot be 0 and x cannot be -4. And writing that in our lovely interval notation, we're going from -infinity to -4, union -4 to 0, union 0 to infinity. So that's pretty much it in terms of combining these functions. We worked a lot with it last year in Algebra 2, but just as a reminder, check your domains. Make sure that they work or that you have any sort of limits in here when you introduce a denominator. Or if you had a domain to begin with, make sure that's included in your final answer. So besides function operations, we of course have composites of functions. And we love composites because what it is running one function through another. So we can either have something like f of g of x, right, where we're taking g and inputting it into f. That's also equal to, just a little bit of this notation, is this f of g of x, that open circle there, right? This little open circle means f of g, meaning you're going to put g of x into f of x. And you're going to take the outputs of g of x. So we're going to go ahead and talk about those outputs now. So let's first go ahead, just like what we did, we now have these two different functions. We have f of x and g of x. So let's go ahead and find f of g of x. Well, that's going to go ahead, I'm going to take the square root of x minus 4 squared plus 1, and I'm going to say x minus 4 plus 1, because that square root square goes away, leaving us with x minus 3, which is super cool. It's just this linear function. But let's check in on it. I'm first using g of x, okay? And when I think about any inputs of g of x, I can only use numbers from 4 to infinity. So I can only start on this one. I have a domain of 4 to infinity. So even though that this is a linear function, it's going to be from a linear function starting at 4 and going to infinity. And that is because I started with g of x, meaning that I could only use inputs from 4 to infinity. That's going to be a little bit different when we flip it around. But first, let's go ahead and remind ourselves that yes, we can do this with numbers. So let's find f of g of 5. And because we did already find f of g of x, we can just plug that into the function and say, well, duh, that's going to be 2. Or you, of course, have the option to first find g of 5. That's going to be the square root of 5 minus 4, aka the square root of 1, aka 1, and then plug that in, that output, into f, which is going to be 1 squared plus 1, which is equal to 2. Same exact thing, right? We got 2 here, and we got 2 here. So it doesn't matter which way that you do it, kind of depends on how you set it up. If you found f of g first, it might be easier just to plug it in. All right, let's go ahead and let's flip this around. So we have g of f of x. We're now solving for this one, right? G of f of x. So this part is going to be a little bit different with those domains. We're starting with f of x, and if we'll notice with f of x, we have any number that we want. It doesn't have a domain restriction, so we can plug in any number, right? I'm thinking about it. Right here, I have x squared plus 1. That's going to be negative infinity to infinity. I have any real number system. Okay, so far, I'm good. I can plug those in. But when I look at my g of x, right, I can only take certain numbers into g of x. So my final answer here is going to be x squared, the square root of x squared minus 3. And for my domain restriction, I know that I can go from negative infinity to negative square root 3, union square root 3 to infinity. And there's a few different ways that we know that. We know that because if we're looking right here, we know that x squared minus 3 has to be greater than, greater than or equal to 0. It's still a little bad. We're going to change that sign there. And then we kind of solve that one, and we know that x squared has to be greater than or equal to 3, doing our flips and solving from there. That's one way that we can think about it. The other way that you can think about it is that, hey, I know from my g of x I can only input values from 4 to infinity, meaning that I could say x squared plus 1 is greater than or equal to 4, and you end up getting the same inequality here. X squared is greater than or equal to 3, and you can think about that on your number line, and we have negative square root 3, positive square root 3 with your parabola. That didn't pop in, but we have your parabola here, and so we have positives, negatives, and positives. And that's one way that you can think about it. So the main thing that you want to remember is that your composites have to go in order, right? So you're thinking about, hey, what order, right? Remember for those, check those domain restrictions, what order are they going into?